Alright, welcome back. This is part 2 of 7.5. I think this will be the last video of new material for the year. So, it's sad for me, but you're probably happy about that. Let's go ahead and get started here. So, in the last video, we talked about how to do certain things with logs if we had certain information. So problems like this one, where we're given the log of something, the decimal approximation, and we want to approximate something different with the same base. And we did several problems where we would have to break this number down perhaps, and then do some other things, and figure out what number that is. So this first example, actually these first two examples, are a little bit of that kind of review, but we might find as we go through these, there is something else we need to know. But let's go ahead and get started here. We should be able to start example 3 the same way that we've done some of the ones from the last video. We know that log base 5 of 6 is this, and we want to approximate log base 5 of 216. So, our first thing that we would want to do is break this 216 down so we can re-express this somehow. If we're lucky, there will be a 6 in there somewhere that we can use. So we break down 216. It's not immediately obvious how that breaks down, but again, we want to find a 6 somewhere in there. So the first thing I would try and break down here is to see if we can divide 216 by 6 evenly. So I'll bust out my calculator here. 216 divided by 6 is 36. So 6 and 36. I don't know about you, but seeing that makes me very, very happy because I know 36 also breaks down into 6 and 6. Okay. Now, each of these 6's could break down into a 2 and a 3, but remember, the information we have here is log base 5 of 6. Not log base 5 of 2 or 3. So we actually don't want to break these down anymore. And we want to be able to express 216 in terms of 6's. This is 6 times 6 times 6, so that's 6 to the third power. Okay. So that should help us figure out how to approximate this using this information. So let's go ahead and write down what we've got here. Log base 5 of 216 is the same thing as log base 5 of, we'll write 216 this way, 6 to the third power. This is where something new needs to come into play. Because in the last video, when we had something like this, each time that we had something like this, the base of the log and this base were the same number, and we just said it equaled this number. But check it out, this time these numbers are different. So we can't use that rule. We've got to do something different. So there is another rule about logarithms. We can express this in a way that doesn't involve logs. Well, not in a way that doesn't use logs, but in a way that we can use the information we have. Because we don't know what log base 5 of 6 to the third power is. We only know what log base 5 of 6 is. So we need to get this 6 to the third power and somehow get rid of this exponent so we just have log base 5 of 6. But you can't just pretend this doesn't exist. But here's the thing. So let's say we have something like this. Log with some base of x to the q power. Okay. There is another way to write this. And there was actually a problem, I think it was the last problem in the last video, where we had something like this. And we wrote it a certain way. But there was an easier way to do it. A nice thing about logs is, we can take this exponent and put it out front. these two things are exactly the same. So if you're taking the log of something to a power, you can take that exponent and move it right out front of the log. It's awesome. Okay? And this is really going to come in handy right now, because what we have is this, and we want this exponent to move. And what this rule is saying is we can take this exponent and put it right out front. So that's what we're going to do here. So we've got log base 5, excuse me, 6 to the third power. We can take this exponent and move it right out front. So this is equal to 3 times log base 5 of 6. How does that help us? Well, log base 5 of 6 is this, which we can approximate this way. So we're just going to plug in this number for log base 5 of 6. This is approximate. Oh no, I've made a mess. Okay, so this is 1.1133. Now all we have to do is multiply that. 3 times 1.1133. This actually works out really well. You don't even need a calculator. You can just multiply each digit by 3 here. .3399. Right? So, same thing we've been doing in the last video. We're approximating logs. We break down this big number in a way that lets us use the information we have. If we had kept breaking these 6's down to 2's and 3's, we would have been stuck. So from the very beginning, think about what you have and how you're going to get there. So we re-expressed this, and then we used our new information because these bases were different, and that allows us to take that exponent and put it out front. Then we just use the information we were given to plug that number in and multiply. All right, so the multiple choice problem that's right below that one in the notes, multiple choice problem 2. Again, we're given some information here, this time log base 4 of 6. And we want to approximate log base 4 of 1,296. So, if you feel comfortable having seen this one, pause the video, take a look, try it out. Steps should be kind of similar to this. You'll probably end up using this, okay, to get to the answer. So pause the video if you want to. Try and work it out yourself. Come back when you're ready. All right, let's do this. We want to approximate log base 4 of 1296, but all we know is log base 4 of 6. So not only am I going to be breaking this number down, but as I do that, I'm going to be looking again to see if I can break it down by 6's. Because if I can, it's going to be very similar to what we've done here. So I'm going to do 1296 divided by 6. You're never going to believe this. It's 6 times 216. Why am I laughing about that? We already know how 216 breaks down, right? That's what we do over here. 216 breaks down into 3 6's. So I'm just going to do that all at once. 216 becomes 3 6's. We've got 6 here. So what that tells us is 1296 is just 6 to the 4th power. Okay. It just so happens that in both of these problems the number here was 6. It might be something else. If this number had been an 8, I would have tried to divide this by 8 and see how that worked out. Okay. So we've got 1296 is 6 to the 4th power. So I'm going to rewrite this as log base 4 of 6 to the 4th power. Now, this brings up an interesting point. We know that if this base and this base are the same, that the answer is just what the exponent is. Here we've got this, the base of the logarithm and the exponent are the same number. That actually doesn't mean anything. I know you're trained to see patterns in math, and you see the pattern that these are the same number, and you're like, ooh, does that mean the answer is 6? No. You can only do something with this if the base of the log and this base are the same number. Since they're different, we're going to be using this rule. The fact that the base of the log and this exponent are the same, unfortunately, doesn't tell us anything. But we can take what we've got here and use this rule. All this is telling us is we're taking that exponent and putting it out front. So we're taking this exponent and putting it out front. Okay, so this exponent has moved into the front. From here, well, again, we want to know this as a numeric answer. So there's got to be some way we can turn this into a number. Isn't this the information that we were given at the beginning? Log base 4 of 6. Yes. So we're going to take log base 4 of 6 and turn it into 1.2925. Okay, I'm not as brave with this one. I am going to pull my calculator out to do that multiplication. 4 times 1.2925, that is 5.17. So, these problems are very similar. I don't want you to get tripped up trying to look for patterns that don't tell you anything. Okay? Just know that if you've got a log of a base to a power, you can put that exponent out front. But if these bases do happen to be the same, it's much easier to just say, okay, that's just 4. Okay. Sorry, I was thinking about the case where these numbers were the same and what would happen if you put the exponent out front. So let's say you had log base 7 of 7 to the 3rd power. We know this is 3. This is equal to 3 because these bases are the same. But what happens if you use this rule? You can take this exponent and put it out front. And so this is 3 times log base 7 of 7. Log base 7 of 7? This is saying 7 to what power gives you 7? This is just 1. So it's still equal to 3. So you can still use this rule even if b and x are the same number, but you're just going through extra steps. You're going to end up with just whatever that exponent is. Okay? Didn't necessarily need to know that, but I just wanted you to know that it does still work. Math does make sense in that way. I'm just going to erase this. If you wanted to write that down, you can rewind the video back to where it was. I wanted to branch out and use more colors so it was a little more fun to watch, but man, some of these colors are really hard to erase on my board. All right. So, for the last couple examples for this video and for the notes and for the year, perhaps, let's do something a little different. Okay? We're not going to be approximating logs anymore. We're going to be solving equations that have logs in them. Now, we've done this in a prior section, but that was when we had just one log on one side of the equation or one log on both sides. Check out what we've got in this example though. We want to solve this equation. How many logs are there? 1, 2, 3. Okay. And it turns out there's nothing we can really do with the logs if there are more than one on one side of the equation. So if you're asked to solve something that has more than one log on one side of the equal sign, what you need to do, your goal right now, is to get log of something equals log of something. Okay? You want to get it so there's one log on each side. Why do you want to do that? Well, we know from what we've talked about in the past, if we can get log of something equals log of something, well, as long as the bases are the same, you can get rid of the logs and just deal with what's left. That's what we want to get at. So, we need to find a way on this side of the equation to get this to be just one log. That's our goal here. So, I'm going to write what we've got. I'm just copying down right now the original problem. All right. So, what might come into play on these last couple examples is also the fact that we've taken a lot of rules that are similar to this one, and we've gone from what we have here to what's on this side. But the nice thing about equations and rules in math is not only can you go from this to this, you can go from this to this. It all depends on what information you start with. So, in these two problems, we started out with something that looked like this. We took that exponent and put it out front. But check out what we have here on this side. We've got 4 log base 2 of x. Now, what we want to get at, we're not allowed to have anything in front of the logs. So this 4 right here is a problem. We need this 4 to move so that it's not out in front of this log. So where can this 4 go if it's out front of the log? Four is Q. What this is saying is if you've got something out front of the log, you could put it back up in the exponent. So we can take this 4 log base 2 of x and move this 4 right into the exponent here. So we can make this log base 2 of x to the 4th power and keep everything else the same. Okay? So we're still using this rule, but instead of going from this to this, we've gone from this to this. And the reason we did that is we're not allowed to have this 4 here. Nothing is allowed to be in front of these logs. Otherwise, we wouldn't be able to cancel them out. Okay, so now we've got this. There's nothing in front of any of the logs, but we still have the problem where we've got 2 logs on this side, and we want there to just be 1. So what can we do to turn 2 logs into 1? You may remember in a prior video, if we've got the log of something minus the log of something else, that means we can take these two things and divide. Again, we're going backwards. So in the notes, if you've got the notes up, we're using what they call the quotient property of logarithms in reverse again. So last time, we had the log of like 49 over 35, I think it was, and we changed it to the log of 49 minus the log of 35. But we can also do it backwards. If we've got the log of x to the 4th minus the log of 5, I usually don't talk about the bases. The bases doesn't really matter. If we have log of x to the 4th minus log of 5, we can write that as the log of x to the fourth over 5. Take these two logs that are subtracted and turn it into this. So we're using that property in reverse as well. This still equals log base 2 of 125. All right, so we've used two of our rules so far. We put the coefficient out front into the exponent so that nothing was in front of any of the logs. And then to get just one log on this side instead of two, we turn that subtraction into division. Now we've got log of this equals log of this. We've got to our goal. So at this point, we can take our logs, get them out. Let's just yeet these logs out of existence. Okay. And we'll just deal with what we have left. That's x to the fourth over 5 equals 125. What is it we're trying to do again? I've forgotten. Solve. Solve means get x by itself. So if we've got this, our next step getting x by itself, probably want to get that 5 over there. Since we're dividing by 5, let's just multiply both sides by 5. That's going to cancel these 5s, exactly what we wanted to do. X to the fourth equals, this is 5 times 100 plus 5 times 25. So that's 500 plus 125, that's 625. So x to the fourth equals 625. We're so close. We've only got one more step left. If we've got x to the fourth, how do we get x by itself? We take the fourth root of both sides. The fourth root of both sides. The fourth root is going to cancel with this exponent of 4 and just give us x. And it equals the fourth root of 625. I'm not sure if you can use your smartphone's calculator to calculate this. It's possible that you can. I'm not exactly sure right off the top of my head how you would do that. But what this is, it's saying there is some number that if you multiply it by itself 4 times, you get 625. Some of you might know what number that is, but if you want to check, you can do guess and check here. Multiply the same number by itself 4 times and see what gives you 625. So let me try 3. 3 times 3 times 3 times 3. That's 81. Too small. We need a bigger number than that. What about 4? 4 times 4 times 4 times 4. That's 256. Still too small. Make it bigger. 5 times 5 times 5 times 5. 625. So x equals 5. Now, the very eagle-eyed among you might notice 5 is not the only number that is the fourth root of 625. This is really plus or minus 5. But if we say that x could be negative 5, so really this is plus or minus 5, if we're saying x equals negative 5 as a solution, then that means we should be able to plug in negative 5 for x up here at the very beginning. But if we do that, that would mean we're taking the log of negative 5. That doesn't exist. Can't take the log of a negative number. So it turns out it is just positive 5. So x equals 5 is your only solution here. Okay. All right. So for this problem, we did use a couple of our rules that we learned about in this section, but we used them in the opposite way that we're used to. Okay? Instead of taking an exponent and putting it out front like we've done here, we started with the number out front, the coefficient, and put it back into the exponent. We then took the difference of two logs and turned it into a log of a quotient. Okay? From there we got rid of the logs and just solved for x. Okay? But using those rules in the other direction than we're used to, I want you to know that that's a thing you can do. Totally doable. Okay. So only one equation left to solve here. This is our last problem. We want to solve that. Okay. So again, we've got log, log, log. Two logs on one side. We want our goal still to be this. Log of something equals log of something. So anything about this equation that doesn't look like this needs to be fixed. So on the right side of the equation, we have log base 3 of 150. That looks fine. We're not going to have to look at changing anything over here. All of the work that we have to do at the beginning has to be to get everything on this left side to be log of something. Right? So, let me copy this down. Two log base 3 of x minus 2 minus log base 3 of 6 equals log base 3 of 150. Again, to get to our goal where we can get rid of the logs, we're not allowed to have anything in front. So if any of these terms has something in front of a log, we need to fix that. Again, we've got 2 out front, just like we had this 4 here before. So we move this 4 into the exponent. Okay? That is using this rule again. We're going to do that here with this 2. Okay, so we're going to move this 2 into the exponent. It looks a little different because this is x minus 2 in here. Okay, the exponent will go at the end, outside the parentheses. So that's going to look like this. Okay, so that 2 out front is now x minus 2 squared. Okay. So you'll notice here, we've still got 2 logs on this side, and they are subtracted. Okay. So the way we're going to deal with that, again, is going to look really similar to this one here. If we have the log of something minus the log of something else, we can write that this way. So we're going to do the same thing over here. Okay. This might be a good place. Pause the video for a second. See if you can write what that next step looks like. Once you do that, play the video and see if you got it right. This is going to be log base 3 of x minus 2 squared over 6. Equals log base 3 of 150. Okay. Again, we write that as a quotient, this over this, because this is a minus sign. If this were a plus sign instead, that would change what this looks like. If this were a plus sign, this would actually be x minus 2 squared times 6 instead of divided by 6. Okay, you'd be using that other rule backwards. Okay, but this is division because this was a minus sign. Same thing here. All right, the reason we've done those two things is because now we have log of something equals log of something else. We are now to what we want. This is where we can get rid of those logs. Bye-bye. Okay, we write what's left. X minus 2 squared over 6 equals 150. again, our goal here is to solve. We want that x by itself. So, I think that 6 needs to be taken care of first. To get it to move over to the other side, we multiply both sides by 6. We're just doing algebra now. This is not logs anymore. Okay, these 6's cancel. We have x minus 2 squared equals 150 times 6. That's 300 times 3, 900. X minus 2 squared equals 900. At this point, maybe some of you are looking to add 2 to both sides, but you can't do that yet. All this stuff is stuck inside these parentheses. What you need to deal with next is this exponent of 2. If something is squared and you want it to be unsquared, how do you unsquare it? Take the square root. So we're just going to take the square root of both sides here. This square root is going to cancel out with this exponent of 2, essentially. That'll give you x minus 2. And you need the square root of 900. That one you should be able to do on your calculator. Even your phone's calculator. Just type in the square root of 900. You should be able to get that. So square root of 900 is 30. So x minus 2 equals 30. And again, technically this is plus or minus 30. But again, if we put a negative 30 here and then move that 2, we're going to get a negative number. And we can't take the log of a negative number up here at the top. So I'm just going to leave this as a positive 30. Okay, but it is something you should look at as you solve this. Move the 2, or the negative 2 over by adding. So plus 2 to both sides. X equals 32. X equals 32. Okay, and that is C on your sheet. There you go, sheet. This one was C as well. Okay. So, solving these logarithmic equations, if there's more than one log on both sides, you're probably going to have to use multiple of the rules that we talked about in this section. So I just want you to be aware it goes in both directions. If you've got something that looks like this, but you can't use it the way it is because you don't know what this is equal to, try moving stuff around. This exponent goes in the front, now you've got this, and you can use the information that you were given. Okay? Sometimes you'll need to go the other direction, right? Sometimes you'll have something that looks like this, something that looks like this, but you need this number to move somewhere else. You can move that right back into the exponent, and that will allow you to continue. Okay? It's all a matter of what you have versus what you need. So, again, this stuff is not very easy. This is some of the hardest stuff that you've dealt with this semester. So if you've got questions as you work through the homework, which you'll be assigned for the next e-learning day, if you've got questions, let me know. Okay, more than happy to help you out. From 9 a.m. to 12 p.m. on every e-learning day, I am just sitting at my computer waiting for someone to ask me some questions so I can feel useful. I like helping you all out, so feel free to let me know if you need some help with that. I'll do everything I can to help you. But otherwise, this might be the last video of the year, at least that teaches you new stuff. So I guess we'll see you next time. Have a great day.